Hello everyone. For this video, I'd like to explain linear systems with 3 variables rather than 2, which involve 3 terms for each expression and 3 expressions, similar to how it worked for 2 variable systems. So the methods will be just about the same, the only difference is that the exact details will be different. In particular, if we are given a system like this, we see that there's probably no easy way to get one of the variables directly in terms of the other two, so we would do the method of elimination. We first note that we can eliminate y in the second and third equation relatively easy, so we do that. And we can also eliminate z from the second and third equations as well, so that in total, after everything is done, we get 15x equals 30. This means we have found x equals 2. So we can trace back our steps, i.e. from before we eliminated z, and get a value for z by choosing the equation 5x plus 5z equals 15. So we see, after we do the algebra, z equals 1. And lastly, we can substitute in the exact values for x and z and solve for y. In the first equation, because we did not eliminate y in it, and state that y equals negative 1. We see, with a specific example of all the steps, that the method of elimination is a lot more tricky with 3 variables involved rather than 2, because you have to have careful planning with what you choose to eliminate, which was not as much of a problem with the 2 variable systems. So now we will see how the method of substitution works with these kind of systems. We can see in this system that we can get y by itself pretty easily as 4x plus 5. But the caveat here is that even though we did do the correct substitution, we cannot get specific values for x and z yet, because we still have 2 unknowns in each equation rather than simply 1 unknown. But the good news is, once we simplify it, we have a system of 2 variables which we know how to work with already. So we try the method of elimination and see we can eliminate z pretty easily, which gives us negative 12x equals 6, or x must be negative 1/2. So now we can compute z directly by substituting in the value of x we got to one of the equations, and saying in this case z equals negative 4. So now finally, we can compute an exact value for y by simply plugging in the x value in the substitution we derived earlier. And this computation states that y equals 3. So in conclusion, we have finite values for all 3 variables, which to recap are x equals negative 1/2, y equals 3, and z equals negative 4. Now that we have figured out how to solve systems of 3 variables, we can discuss systems involving equations that are more complicated than linear functions, which are called nonlinear systems. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.